Hey guys, welcome back. This is part 2 of making a third-person character controller in Unity. If you haven't already, check out the first part. A link for that will be in the description down below. So in the previous tutorial, we finished implementing the ground check mechanism for our character controller and integrating that into our animator. So we had basic animations working of the character in his idle state. So starting out inside of our character controller class, I'm going to create a new vector 2 to handle the movement of our character. I want to add the fixed update method and then also the onMove method that coincides with our player inputs. That one takes in an input value as its parameter, and we'll just want to set our new movement vector 2 to be whatever that value is. With our movement inputs working, we can go ahead and implement the animations for the movement to go alongside that. So within our fixed update method, I'm going to set the values of our two floats, the forward float and the right float within our animator controller, and I'm going to set those ones up as the movement input that we've just received. Back inside of the Unity scene, we can see that the player now moves using his animations when we hit WASD. Before we get into the code, I'd just like to explain how we're going to be implementing the character controller. So you can see in this illustration that we have the wizard, and we're going to be moving him along the three axes, X, Y, and Z. We're going to be doing that by using Unity's input system. However, because it's a third-person character controller, if the character's moving, he's always going to have to facing forward. The camera's direction is going to move as per the mouse input, so we need to make sure that the character's vector forward matches the camera's vector forward. However, I wanted to implement the ability for the camera to rotate around the player when the player isn't moving. So to do this, we're going to create an empty game object that isn't a child of the character, but lerps towards the player's position, and is always facing forward relative to the camera's forward vector. And once the player starts moving, we can lerp his forward vector towards this empty game object. This way, when the player starts moving, his forward vector will always eventually equal the camera's forward vector. So back inside the code, I'm going to create a new method to move the character. We'll also want to add that one to our fixed update loop. At the top of the class, I'm going to create a private transform for the follow target. We'll be using this transform as the empty game object that maps to the camera's forward vector. So in our awake method, let's set that one up by creating a new game object, and I'm going to call that one follow target. Back inside of our move character method, we're going to need to find our forward and right vectors. I'm going to do this by using the follow target's local forward and follow target's local right vectors, and just setting the y values to 0 because we don't need those components to move our player. Then I'll go ahead and create another local vector 3 called difference. What I'm going to be using this one for is multiplying my forward and right vectors with the movement that we're grabbing from our input system. I need to multiply my forward vector by movement's y value, as that represents the W and S keys, and I need to multiply my right vector by movement's x value, as that represents the A and D keys. I'm also going to create a new float for the movement speed and also multiply that one out by time.delta time. To fix my errors, I'm going to create the speed variable just at the top of my class and make that one serializable. Back inside of our move characters method, we're going to call our rigid body's move position method. We'll want to pass in our transform position added by our difference. This method will essentially move the character's position using the rigid body component attached, and it'll be moving it at the speed that we pass in using the variable and also the input system that we have provided. Now back inside of our Unity scene, I'm going to make sure that our player has his rigid body's rotation frozen along the X and Z axes. When we hit play, we can see that we got our character controller moving, so everything seems to be working as intended. So back within the code, I'm going to copy my onMove method, and I'm going to be pasting that one and renaming it to onJump. I'm going to be using this method to implement the jump mechanics for our character controller. So what we'll want to do is check if our value is pressed, and if it is, we're going to call the jump method, which we have yet to create. So let's create our jump method now, and within that method we'll want to check if we're grounded, and if we are, we're going to call rigidbody.addForce. Within that method, I'll pass vector3 up as the direction for the force, and then we're going to want to run a mathf.squareroot function, where we'll need to have a jump force variable. So let's go ahead and create that one now at the top of our class. So we'll want to pass the jump height into our square root function multiplied by -2. And then we'll also want to multiply that one by physics gravity's y component. Now I'll want to pass in my final parameter of force mode, which will be velocity change. And then I'm also going to fix the error by multiplying my vector3 up by the math square root function instead of adding a comma there. And then with that done, we should have our jump method ready to go. Back in the Unity scene, we can see that the jump animations are hooked up properly. So we've got the initial jump animation, and then he sort of transitions into the falling state, so it's working as intended. So the final thing we're going to implement onto our character controller is a run mechanic. So we'll start out by creating a new float that's serializable. And we're going to call that one run multiplier, and I'm going to set that one to a base value of 1. And then we'll also want to create a private boolean, which I'll call running. Now further down in our code, I'm just going to copy this onJump method and paste it in, and I'll want to rename that one to onRun. And that just matches the player inputs that we created before. Then I'll also go ahead and create a new method, which we'll call toggleRun. And we'll just want to replace the jump method within our onRun method to the toggleRun method, which we just created. And that'll just be triggered every time the value is pressed. So within our toggleRun, I'm just going to set the running flag we just created to be equal to not running. And then in our moveCharacter method, we're going to want to multiply the local variable of difference by an inline if statement value. The inline if statement is going to take in running as its condition, and if we are running, we're going to want to multiply the difference by 1 plus the run multiplier. We'll want to add the colon for our else check, and then we'll just pass in one float, as that's what we'll be multiplying the difference with if we're not running. And with all of that done, our running mechanic should now work, so let's jump back into Unity. So we can see now with our running implemented that the character is moving a lot faster. We've got our jumps working as well, and the character moving with different animations. So our character controller is really coming together at this point, and it's starting to look more like the final product. The final thing we'll need to do is implement the camera and have that one control with the mouse input. So we'll be getting to that one in the next part. Thanks for following along with part 2 of this micro-series. The third and final part will be released next week, and we're going to be making the third-person character controller's camera, and it's going to be controlled by the mouse's input. I've recently created a Discord community channel where you can find help to all of your game dev questions. It's also a great place to come, hang out, and play some video games. So if you're interested, a link for that will be in the description down below. As always, if you're enjoying the content, please hit that like and subscribe button down below, as it helps the channel out a bunch. Thanks for watching, and have a great day.